Today we are going to see about the question of the T1. Which of the following solution to ux plus x square yx equal to 0 with the boundary condition of ux comma 0 equal to e power x? First we take the equation, then boundary condition. We know that p plus q equal to r. Then we wrote dA by x by p equal to dy by q equal to du by r. So for that format, we dx power x1, dy power y is x square. For u, there is 0. So cross multiply, this means du equal to 0. Then we integrate means u equal to c1. Then take this term and multiply means x square dx equal to dy. If we integrate means x cube by 3 equal to y plus c2, and take this y this side, x cube by 3 minus y equal to c2. So we get c1 c2, and this is the form c. We know that c1 equal to pi of c2 for the function of c2. So c1 is u and c2 is nothing but x cube by 3 minus y. Our boundary condition is e power x. So e power x equal to u equal to e power x. Okay. So e power x equal to pi of, which means boundary condition at x place it will be 0, and u form u of, generally it is referred as u of x. So e power x equal to pi of x cube by y, and we take this as m, x cube equal to 3m, x equal to 3m the whole power 1 by 3. So our pi m will be exponential of, because pi m equal to exponential of 3m whole power 1 by 3. Then u equal to, what is our u equal to exponential of x. So x is 3m the whole exponential of x. So u equal to exponential of 3 into, this is pi m is obviously u, so exponential of 3 into, we know that m equal to, m is x cube by 3 minus y and whole power 1 by 3. So then u equal to exponential of this 3 getting cancelled, so x cube minus 3y whole power 1 by 3. So our answer is exponential of x cube minus 3y the whole power 1 by 3. Hope you all understand. Then the next question is, which of the following solution of the Laplace equation uxx plus uyy equal to 0 in the unit disk of d equal to x comma y, x square plus y square less than 1. So the given option is here. So first we have to prove this by taking each one. So uxx, if we take the derivative with respect to x means this, and derivative with respect to y on 2 times means we get this term. So if we equate means it will not be equal to 0. So first option is not correct. Then we have to check each of the options, and for second term we choose this, and if we take the derivative with respect to x means ex cos y plus ey cos x, and again we take the derivative with respect to x means ax cos y minus ey, because cos x derivatives minus sin x, so uxx this term, and if we take uy and take the double time derivative means this terms get cancelled. If we add these terms, is equal to 0, and ux is 1 plus x divided by, this is the form of u by v, so v u dash minus u v dash divided by v square, the formula of this derivative. So v minus u dash is obviously 1 minus here v u is this one, and dash is derivative of this with respect to x means 2 plus 2x the whole square. So if we multiply and get cancelling means we get this term ux equal to y square minus x square minus 2x minus 1 divided by this one, and again we have to take u by u by v method, so v u dash minus u v dash divided by v square. So again we take means with respect to this one as it is, and we take the derivative of u dash means we get minus 2x minus 2, and minus v dash is 2 into this term, and again 2x2 plus 2x and this term divided by whole square. So if we do the step means we get this one answer, and then with respect to y if we deal means we get this form. So uxx plus uyy is equal to 0. So it's proved. So obviously, and 2 3 4 are our answers. Hope you all understand, and thank you.